Acid strength depends on two things: the strength of the XH bond and the polarity of the bond. So CHCl3, although it has hydrogen in it, is not acidic because the CH bond is a very strong bond. The stronger the bond, the weaker the acid's going to be because we want to sever this HX bond. It's also nonpolar, which means the electrons are not going to be pulled, weakening that bond. So again, it has to do with the strength of our bond and polarity. If we look at HF, HCl, HBr, and HI, HF is the most polar bond and HI is the least polar. So you would expect HF to be the strongest acid and HI to be the weakest acid based on polarity. But if we look at the strength of those bonds, HF actually has the strongest bond. So although it's the most polar, because its bond strength is so strong that hydrogen can't come off in solution as easily, making that a weak acid. HI has a very, very weak bond in comparison, and so even though it's not as polar as the other three, it actually is the strongest of those four. HCl, HBr, and HI are all strong acids though, so they all dissociate 100%. They all have relatively weak bonds, and they're all very polar. Oxyacids have the general formula of HOX, where the hydrogen is attached to an oxygen atom. As the number of oxygen atoms increases, so does acid strength. So HNO3 is stronger than HNO2, and H3PO4 would be stronger than H3PO3. The reason for this has to do with the strength of that OH bond again. So let's look at some pictures and look at it a little bit closer. Here we have HClO2, HClO3, and HClO4. These two are strong acids with their Ka being around 1 and really large. And then these two on top are weak acids. When you have an oxygen and some other element, that oxygen is going to attract the electrons that are in that bond towards the chlorine or the other oxygens. The more oxygens I have, the more the electrons are going to be pulled away from the OH bond, decreasing the electron density in that bond. When the electron density in the bond is lowered, this bond is weaker, making it easier to break apart, allowing the hydrogens to come off as ions. Notice HClO4 has 3 oxygens, attracting the electrons in that OH bond, decreasing the electron density, again allowing the H's to come off more easily because this bond is weaker. So why is H3PO4 a weak acid then, while HNO3 is a strong acid? This one has 4 oxygens, this one only has 3 oxygens. Well, it comes back down to polarity. For oxyacids, the more electronegative the X in HOX, so this one has an X of P, while this one X is N. So X is any element that wasn't our H or O. The stronger the acid, or the stronger acid is going to be the more electronegative X. Nitrogen is more electronegative than P, which means nitrogen will be more effective at attracting the electrons away from that OH bond, weakening the OH bond, allowing more hydrogens to come off. You may see multiple choice questions where you just have to determine which acid is stronger. You may also have to explain. So in this problem, first we need to look and see what's different about these two acids. The only thing that's different is this one has 3 chlorines while this one has 3 hydrogens. we know that chlorine is more electronegative than hydrogen. So that's the first thing that we should be stating, because the only difference has to do with hydrogen and chlorine. And the more electronegative it is, it'll be able to attract electrons better. So chlorine is more electronegative than hydrogen. So chlorine will attract the electrons in the OH bond more than hydrogen will. So the OH bond will be weaker in CCl3COOH, producing more hydrogen ions. So again, this bond here will be weakened, allowing that hydrogen ion to come off, leaving us with everything else. Weaker bond lead to stronger acids because it will produce more hydrogen ions in solution. Go ahead and pause the video if you need to finish writing down your explanation. Go ahead and pause the video and try figuring this one out on your own. Why is H2SO4 stronger than H2SO3? Restart when you have an explanation. The first thing you should have stated was the difference. This one has 4 oxygens while this one only has 3 oxygens. So H2SO4 has more oxygens than H2SO3. And then you need to state, why does that matter? So the electrons in the OH bond will be attracted more towards S in H2SO4, which means that the electron density in the OH bond will be lower in H2SO4. The OH bond will then be weaker, producing more H+ ions. So as the electrons are pulled away from the OH bond, that leads to a lower electron density, which in turn is a lower or a weaker OH bond. Go ahead and pause the video if you need to. Fix anything in your explanation. Restart when you are done. Finally, we have anhydrides. When you have a nonmetal oxide in water, it's going to produce an acid. Because the bonds between sulfur and oxygen are strong, they're going to attract the hydrogen in water to make an acid. While metal oxides in water make bases, being metal hydroxides. Because when you put a metal oxide in water, it's ionic, it's going to break up into sodium and oxygen ions, and that oxygen ion is going to attract the hydrogen in water to make hydroxide ions, which then can combine with the metal ions. So nonmetal oxides in water, when placed in water, will make acids. Metal oxides in water will make bases. So go ahead and pause the video and determine if the following oxides would produce acidic or basic solutions when placed in water. Restart when you're done. For the first one, that was a metal, so it should have been basic. This next one is a metal, so it should be basic. The third one is a nonmetal, so it should have been acidic. And the last one is a metal, so it should have been basic.